This is the third video for section 8.2. We're going to solve a parallelogram. We have a definition for a parallelogram. We have 4 theorems. Plus, we have a lot of knowledge about triangles that'll help us here too. The first thing we want to do is find the distance from N to M. Since this is a parallelogram, those diagonals bisect each other. So N to M is 5. K to M would be the entire diagonal, so that would be 10. The measure of angle JML would be this entire angle. I'll highlight it in light blue. That entire angle. Now, notice how this angle, I'll also highlight it in light blue, is 82 degrees. That means this angle over here, altogether, has to be the supplement of that other angle. So we'll call that 98 degrees. So angle JML is definitely 98 degrees. Okay, now angle KML, that's part of that 98 degree angle that we just found. So in an effort to make this easier to look at, we'll just erase that for a second. This angle is 35, and the whole entire angle is 98, remember. So take that 35 away from 98, and that'll give you the measure of angle KML. J to K, how far would that be? Well, we don't know the right side, so we're not going to be able to figure out the left side. But what we do have is a triangle that looks like this. We have the measure of angle J is 82 degrees, and we have the measure of this angle down here is 35 degrees, and we know that side is 10. You have 2 angles and a side that isn't included. Could you find this other side? We'll just call it X for right now. Yeah, you're going to use your law signs. Okay, so hopefully you remember how that goes. 10 over the sine of 82 has to be the same thing as the side that you want over the sine of 35. We're going to cross multiply. So we're going to multiply 10 with the sine of 35 and then divide by the sine of 82. Take a second and type that in. Make sure you're typing this in also. Make sure you get the same thing. Looks like 5.79. Okay, no, that's not exact. That's a rounded answer. So we don't want to use that rounded answer to calculate something else. How far would it be from J to M? Okay, now that's the bottom of this triangle. So we can use the same basic setup here. If we use that same picture that we redrew, we can calculate the measure of that angle at the top, where the K is. Don't call it angle K, but you can figure out what it is. This angle at the top is going to be 63 degrees. Okay, so if we want to find that distance from J to M, we'll call it Y. We're going to set up the law of sines again. We're going to say that Y over the sine of 63 has to be the same thing as 10 over the sine of 82. So it looks just like that other proportion, only we're going to divide by something, we're going to multiply by something different this time. Okay, so we're going to take 10 times sine of 63, and we're going to divide that by sine of 82. That gives you about 9.00, and again, it's not exact, that's a rounded answer. We also want the distance from J to L, and that's going to involve a different triangle altogether. So we're going to draw that guy up here. We want to find that distance. Maybe we'll call it lowercase z. Remember that angle's 98 degrees. Yeah, and this guy is 9.00. The only issue with that is it's not exact. So watch yourself there. What else do we know? We also know this angle, or this side on the right, is 5.79. Again, that's not exact either. So you have to use two things that aren't exact to maybe find an angle measure first here. Okay, so that angle right there where the blue dot is, it's not 82 degrees. Is there any way we could figure out what it is? Yeah, well, we can if we use the law of cosines. So that's what we're going to do. We want the measure of angle J. So you're going to have to use the law of cosines. Okay, so we have that arrangement side angle side. So we actually don't need to find that angle we were calling J. We can go right to finding that lowercase z. What do we do with that guy again? I think it's the square root of those guys squared and added. And then you subtract 2 times both of those. And then multiply by the cosine of the angle in between. That looks confusing and messy. And it's going to be hard to use exact answers there. So we're going to type this in exactly the way it is using those rounded answers, which I'm not a huge fan of. But make sure you type it in also. And make sure you get the same thing that I show you. It ends up being about 11.36, and that is not exact because, again, we used rounded answers to find it. If you were to use exact answers, you would have a mess in those spots. and you would have another mess in those spots. Okay, but for simplicity's sake, we'll just call this thing 11.36.